Hello, my name is Andrew Fuller,
I'm Ethan Belisle.
And I'm Anna Tobias.
and we are ME32. We are working on the development of a sanitary product for public surfaces. We have also worked with Manufacturing and Engineering Management, Team 8, as well as our faculty advisor, Professor Jason Lee, and our sponsor, Mr. Virgil Anselmo.
Our team's task was to design and fabricate a portable device that would act as a secondary surface in public settings and dispense membranes. The project was broken down into two parts, the membrane objectives and container objectives. On the left, you can see our membrane requirements as solely being proof of concept, and on the right, you can see the container requirements, and at a minimum, these were the total requirements given to us that needed to be met.
So with these deliverables, we created our final design, which can be seen on the right-hand side of the screen. This design features a two-part assembly, which allows the inner and outer container to fit right into each other, which then seals any inside membranes from being dirty. These membranes are coiled on the inside and can be dispensed into 10 by 16 each sheets, as they are perforated every 16 inches in order to be teared. The purpose of this device is to provide a secondary layer of protection from you and any public surface, stuff as airplane trays, baby changing stations, restaurant tables, etc. The main demographic are parents and elderly people and the immunocompromised, but nowadays this can really apply to anyone. We've also included our size and estimated weight in order to create a compact and lightweight design, which when filled is just over 1 pound.
For proof of concept, our team found indented craft paper to act as our membrane, and this material fit all the requirements listed by our sponsor and also had additional benefits that made it overall the perfect membrane material. And the product was very unique in comparison to industry standard membranes as it's environmentally friendly, being 100% biodegradable, and the fact that it can be customized to fit our specific needs.
We want to showcase some of our notable design features, the first one being our portable and compact size. This container is designed to fit any standard cup holder of a smaller diameter than 3 inches. This way, it can easily be taken with you on the go, whether you're putting it into your car or your backpack or any cup holder. We've also included our ergonomic grip. This has been engineered through numerous iterations in order to be most comfortable for your hand to twist. To do this, we've included an octagonal shape with indented sides so that your fingers can really get in there for a grip, as well as the rounded edges, just so that's comfortable. We wanted to showcase our seal and locking mechanism. Our seal is created by creating tight tolerances between our concentric layers to prevent any contamination from making its way on the inside. With this container, the only way to get into the inside of the container while enclosed is to make it between the layers, and since the tolerances are so tight, it's difficult for that to do so. Our locking mechanism has also been engineered to be as simple as possible. This minimal design allows the two layers to rotate amongst each other with minimal friction and allows the two containers to separate translationally in order for it to be refilled.
Our team created two tests in order to verify our container design. The goal of both of these experiments was to verify the design's durability and reusability. Unfortunately, due to campus closures associated with COVID-19, we were unable to produce a 3D printed container to use for these tests. Our cycle test is a simulation of the translational and rotational movements of the container that focused on the performance of the mechanisms over its simulated lifetime. And our sand test, which was be done in conjunction with the cycle test, ensured reusability of the container and measured the product performance. Completion of both of these experiments would validate our container design and ensure its success in normal use.
Another aspect of our project that was put on hold due to the current circumstances was client prototype testing. And the purpose of this event was to get feedback on the final design of our container. And in order to do this, we plan to invite 20 people as a representation of the general public and then have them rate our container on aesthetic design, refillability, ease of use, and how portable the device was. And the significance of this testing method is that we were able to validate our design and make any major changes before releasing it to the public.
Our team has successfully completed our project deliverables, created a final container design, and developed a proof of concept for biodegradable membrane material. Because of the situation regarding the coronavirus, our team was not able to complete our verification of our container design. We would like to say thank you to both our industry and faculty advisors, as well as all other faculty involved in senior design.